Welcome to this tutorial. I'm solving question number 9 of May-June exam series of 2017, and this question is taken from paper 2-2 of GCSE O Level Physics. The question says figure 9.1 shows a man in a room looking into a mirror as viewed from above. So we have a mirror over here, and this is the man standing who is looking into the mirror. The man can see an image of part of the wall AB in the mirror. So this is the mirror over here, whose one part is seen as the image from this mirror. Point C is the point on the wall closest to A. So there is a point on the wall which is closest to A that the man can see by reflection in the mirror. So this would be the point which the man could see through reflection in the mirror, and this point lies somewhere on this wall AB, and it is at a position which is closest to this point A such that its reflection is seen in the mirror. Now this point is not marked on figure 9.1. On figure 9.1, find point C, draw a line of light from C which enables the man to see the image of C. So we have to mark a point on this wall somewhere, and then when the point is marked, a ray would be generated and would be reflected from the mirror and enters the eye of this man so that he can see the image of C. On the ray that you have drawn on figure 9.1, label the angle of incidence I and the angle of refraction R. So we have these two parts which include this drawing, and in combined they are of 4 marks. So first uh, I'm drawing a ray from the man's eye to the extreme right corner of this mirror, because this would be the ray which would be entering the man's eye from the point where the ray is coming from. Secondly, I have to draw a normal here. A normal is the line which is perpendicular to the surface of the mirror at the point of incidence, and this is the line which is used to draw the angle of incidence and similarly the angle of reflection. So this ray which is drawn from the mirror to the man, whatever the angle is made by the ray, it would be noted as the angle of reflection R. And now with the same angle I have to draw a point over here. So the angle of incidence and the angle of reflection should remain the same. So the ray is coming from this point C of the wall. It strikes the mirror and it is reflected at the same angle as the angle of reflection and then enters the eye of the man. And the line which is drawn in the red, it is the normal which is used to measure the angle of incidence and the angle of reflection. So when this is done, we get 4 marks for this drawing. One characteristic of the image formed by the mirror is that it is virtual. Explain what is meant by a virtual image. It is an image which cannot be formed on a screen and the rays only appear to come from the image, they do not actually come from the image. So we know that the ray, when extended backwards, it looks as if they are coming from the image to the observer, and in real, nothing is coming and no image exists there from where the rays are coming. State one other characteristic of an image formed by a plane mirror. So it is virtual. One other characteristic could be that it is laterally inverted. So this word is very important here. If only inverted is written there, then the marks would not be earned. Otherwise, we could write any other characteristic too. For example, it is upright or erect, and we could also write that it is found at the same distance as the distance of the object from the mirror. The next part says light travels along optical fibers by total internal reflection. State two differences between total internal reflection and and reflection in a mirror. So the first difference is that total internal reflection only occurs when angle of incidence is greater than critical angle, while reflection can occur at any angle. So there is no such thing um, as of critical angle for the normal reflection. Secondly, total internal reflection occurs from dense to less dense material. When the light is coming from a denser medium and entering into a less dense medium like air, while reflection is from air to glass. So the light was in a less dense medium like air, and it was reflected from the surface of the glass, which was denser medium. The next part says the critical angle for light traveling from the material of the fiber to air is 44 degrees. Calculate the refractive index of the material in the fiber. So the formula to be used for this part would be that refractive index is equal to 1 upon sine of critical angle. So it is sine 44, and the answer is 1.4. So the refractive index of the material is 1.4. Light enters the optical fiber from air with an angle of incidence of 50 degree. Calculate the angle of refraction. So now we would be using this formula. N is equal to sine I upon sine R. The value of N is 1.4 for the material. Its angle is to be calculated, and sine 50 is the angle of incidence. So R would be equal to sine inverse of sine 50 degree divided by 1.4. So the answer we get here is 32 degree. So the angle of refraction would be 32 degree in this case. The last part says optical fibers are used in telecommunications to send large amounts of data. Pulses of light travel at almost the same speed as electrical pulses travel along a metal wire. State two advantages of using optical fibers rather than wires for transmitting data. So the first advantage could be that they transmit more data per second, and second one could be less decrease in strength is the other advantage why these are used instead of electrical pulses. So the question ends here with this part.
We try to explain complex concepts in simple language and with effective examples. If you liked the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.